Let's find the composite function n of t of t. So first we replace the t of t by this expression, that is 2t plus 12. So therefore this becomes n of 2t plus 1.2. Now we have to replace the temperature T in this expression n of t by this expression 2t plus 1.2. So when we do that, we get 20 times of temperature square, which means we have to replace this T by capital T by 2t plus 1.2. So therefore this becomes 20 times of 2t plus 1.2 quantity square minus 67 times of temperature T. So we replace that by 2t plus 1.2 plus 31. We will simplify this. First, I'm going to expand this using the identity a plus b quantity squared. That is a plus b quantity squared, and this equals a squared plus 2ab plus b squared. So therefore, I can expand 2t plus 1.2 using this identity, considering a as 2t and b as 1.2. This becomes 2t quantity square. So this quantity square plus 2 times of a is 2t and b is 1.2 plus b squared, which is 1.2 quantity square. And when we simplify this, square of 2t is 4t square, and the product of these three terms, that is 2 times of 2t times of 1.2 is 4.8t plus 1.2 square is 1.44. So the next step, I replace this expression by 4t square plus 4.8t plus 1.44. Now I distribute this negative 7 into the two terms inside the brackets. So negative 7 times of 2t is negative 134t, and negative 67 times of 1.2 is negative 80.4. We then have positive 31, so I put plus 31. Now we will distribute this 20 with all the terms inside the brackets. So 20 times of 4t square is 80t square plus 20 times of 4.8t is 96t plus 20 times of 1.44 is 28.8. We then have the other terms. So let me write down. Now we can simplify this. We have only this quantity 80t square. So I write down as it is. Plus we have the like terms 96t minus of 134t, and when we subtract this we get negative 38t, and we then have the numbers, that is 28.8 minus 80.4 plus 31. So when we simplify this we get negative of 20.6. So this is the expression for n of t, or otherwise we can see that this is the expression for the number of bacteria after t hours. We now determine the time when bacteria count reaches 490. So for this, we are going to use this equation. So this equation basically gives the number of bacteria after t hours. So to answer this question, we have to determine the time when bacteria count reaches 490, which means this expression n of t, this equals 490. So we replace n of t equal to 490 into this equation and solve for the time t. So let's do that. So I replace n of t equal to 490. This equals 80t square minus of 38t minus 20.6. We subtract 490 from both sides and rearrange this equation as 80t square minus of 38t minus of 510.6 equal to 0. So this equation is a quadratic equation in T, where the quantity 80 is A, and this quantity negative 38 is B, and negative 510.6 is C. So we can use the quadratic formula to determine the value of T. So I write down T equals, the formula is negative B plus minus B square minus 4AC under the root divided by 2A. So let's replace negative of B equals negative 38. So this becomes positive 38 plus or minus under the root of B square, which is negative 38 quantity square minus 4 times of A is 80, and C is negative 510.6. This is all over 2 times of A, which is 80. So we can simplify this using the calculator, and we will get two values of T, that is 38 plus or minus 406 over 160. So therefore the two values of T are 38 plus 406 by 160, comma 38 minus 406 divided by 160. So this results in 111 over 40, 111 over 40, or approximately this equals 2.775, and this equals a negative of 23 over 10. This is a negative value. Since T cannot be negative, we can ignore this. So we consider only this value. That is T equals 2.775 hours. So the time required for the bacteria count to reach 490 is 2.775 hours.